Hello students, today we are discussing a new chapter called what we call it as networking concepts. So I think you are familiar with the first chapter what we studied about computers. So we had only one computer and it can perform a number of tasks using hardware and softwares and with the help of instruction and data. So now what we do means we try to connect many computers together. So that is what networking means. So networking means we try to connect one or more computers together so that they are able to exchange the data between anything, any type of digital information can be shared over the network. We'll learn all those. This is a basic idea of what is networking means. Something interconnecting. So there are many computers, they are connected together, that forms network. So that concepts we are going to learn. So in this chapter, we are going to learn the, to understand the uses of networking. So what are the uses of networking and what are the types of networks are available, to understand the various devices used in network, how networks can be formed. So applications are used for networking, how and methods for networking, security, what are securities needed. So this is something about the networking. That's what we are going to learn, this academic. So what actually, I think you already now what we are doing. So what this technique, what we are right now we are using is the contribution of computer networking. So because of network only we are able to talk like this. I think so. It is very interesting. So let us go with in detail. Let us learn something about the networking. So it's a very simple. Keep it in mind. So that is, so many computers are connected. So how you connect? If we connect all together, what are the uses? What are the advantages? And what are the devices we may use? So let us. That's what we are going to learn in this chapter. Okay. So let us come to the introduction. So what does a network means? A network is an interconnection of autonomous computers. So autonomous means they are independent, they are capable of performing any task by themselves. So that interconnection, so we are connecting many computers which are working independently together. That is, a network is an interconnection of autonomous computers. Two computers are said to be interconnected. So I say two computers are interconnected means if they are capable of exchanging the information. That is, when we interconnected means they should be able, they are not just connected by cable, they should be able to exchange the information. So central to this definition is the fact that the computers are autonomous. Again, I said autonomous means independent. So this means that no computers on the network can start, stop, or control another. So because all are independent, so there is in a computer, so nobody can start or stop or control another computer. So this is the basic concept of computer network. So what does a computer network means? A computer network is the interconnection of autonomous computers, and they are capable of exchanging the information, and all are autonomous, and they do not have a start, stop, or control another computers. So or simply you can say what is a network is the interconnection of autonomous computers. Two or more computers are interconnected. They are able to exchange the information. That definition is sufficient. So when you define what network means, so it's an interconnection of, or it's a collection of one or more, two or more computers connected together to share the information or exchange of information. So that is what you can define. There are many ways of defining, but you must include they are independent computers. They are able to share or exchange the information between two or more computers. So such connection or such connection of connection you may call, or collection of computers are called computer network. So there are, what are the goals? Why do we use computer network? So there are many reasons so why we use computer networking. So you can see there. So first is a resource sharing. So the aim is to make all the programs, data, and peripherals available to anyone on the network, irrespective of the physical location of the resource and the user. So resource sharing means, so what happens means, imagine you have a computer resource, maybe a printer or maybe any modem or any type of resources. So maybe a different place. So if you have an organization means, so we may be having 20 computers. So for 20 computers, we have to connect 20 printers or 20 modems or something like this. Now what happens, connect all this 20 computers and all these computers are able to exchange. So then what happens means, so all the programs, any resource, digital resource, which will be connected over this 20 computers, all the people at maybe different physical location. They may be at one computer is in first ground and 28th computer may be in fifth floor. So then still they are able to exchange, and also we can use a limited resource. Same resource can be used irrespective of the physical resource. And also the program, softwares, you have a software means it's expensive. So you install in one computer, the same software could also be used among the remaining computers if all of them are connected in the network. So that is what network, that is the advantage. Resource sharing in terms of software and also in terms of software, they are very advantage, because you can save a lot of money because of computer network. But installation and making the computer network, initial investment will be high. But as you use the network resources, and this is going to be very effective. That is one of the most important aspect of computer network is sharing of resources. That is what the main advantages of computer network. The second is reliability. A file can have copies on 2 or 3 different machines. So if one of them is unavailable, the other copies could be used for military, banking, or many other application. It's a great of importance. What happens, another is reliable. So normally what happens means when you have only one computer and your data, everything is stored, very vital information are kept on that computers. Due to unavoidable circumstance and your computer go down and your computer is not able to perform and there is no way of recovering it. So you have lost everything which was you thought very important. So then that is what happens when you have only one computer. But what happens if you have a network means the same copies could also be kept in 1 or more computers, 2 or more computers, because there are many computers. So if one computer goes wrong, and still you have a possibility of getting that data from other computer. So that's why they said in banking and military and many other applications, it is of great importance, we said, because for them it's a banking. You lost means something it's going to be, we cannot answer to the customers, because I am showing yesterday, draw somebody money and you do not know, and your computers are not able to keep track of the transactions, and you are transacting and it is in one system and it is gone. So that is a difficult. That's why when you have a computers or a computer network, many computers are connected means you can reliable. That's the reliability is possible. And let us come back to another is the cost factor. So personal computers have a better price and performance ratio than a microcomputer. So it is better to have PCs, one per user with the data stored on the shared file server machines. Now what happens means cost factor. Here you can consider one, the software, hardware, because we are sharing the resources. Then what happens? No need to install every software and every hardware component to each computers. So you can use it like a dumb device, just a micro PC, mini computers, or like what we call as a personal computers. They are not much powerful, but still you can connect to the network and you can use all the resources. And maybe the data may be shared with a file server machine. There will be one computer that is called as a server, and all other computers are called workstation or individual computers. So now these individual computers need not be as powerful as the server. It's normal computers could be interconnected. Then what happens? The hardware, software, the cost is installed in one system and use the same thing with all the computers. That reduces the cost involved for each computer. So you have 10 computers and 10 modems, 10 printers, so all individually you have to be installed if you do not have a network. Then cost, obviously it will be expensive. Similarly, the software. So you are buying a software, maybe 10,000, 15,000. So every computer we have to install. So then it becomes a cost very expensive. Then what happens? So if you have a network, so install in one computer, so same data and same software could also be shared among other computers without installing in the individual computers. So that's how the computer cost is effective. That's a cost factor. The next one is very important. That's what we are doing now, communication medium. So using a network, so it is possible for managers working far apart to prepare a financial report of the company. The changes at one end can be immediately noticed at another end, and it speeds up the cooperation among them. They took a specific example, so need not be this only. Now what is a communication media means? When computers are connected together, there are many computers, so all are connected together means so you can send and receive information. That is exchanging already we talked about, and also you can communicate. You can send the messages immediately, and also you can any type of digital files can be sent and received from other places. You can see there they give example of a manager. So maybe a manager it's a different place and he wanted the financial report to be sent to the every like or you are preparing the report or the final report has been generated and it has to be sent to all people who is a subordinate. So that can be sent through to all the computers if they are connected in the network. So the network, if they are connected, so we can send immediately to all the employees. It need not be now what happens earlier, we have to send through the letters. We have to go physically from one floor to another floor, something like, or one place to another place. Now what happens, because computers are involved, so because of they are interconnected, already they're connected, so whatever your notice will be sent and seen immediately on the computers, maybe at different physical locations. So that is a communication medium. The computer network provides excellent means of communication. That's see, I am at a different place and you are at a different place. Still, we are able to communicate. So you are able to read this, what I'm saying, what I'm doing, the videos you can watch. This is because of computer network. So that is what communication media. I think you have understood this communication medium. So these are the main the advantages or the main goals of a computer network is the resource sharing, reliability, of course, the cost factor, and communication medium. So these are the main goals of forming a computer network. So why I have to form a computer network means if someone asks, so this is the main thing is the sharing of resources. That's very important, and you can think it's a reliability, and also you can think cost factor and communication medium. So the first two are very important. First and last points are very important because resource sharing and communication medium. That's what we are doing. That's the main goal of computer network. So now let us learn why do we need the computer network. So what is the need of networking? So what do we form a network means? The file sharing provides sharing and grouping of data files over the network. That's the sharing of resource. Already I've said. A print sharing of computer resource such as hard disk or printers, etc. Already I've told about hard disk, that's hardware components. So email tools for communication with the email addresses, that's already told. Communication, remote access, able to access data and information around the globe, because that's how we are, maybe communication. We may be at different places, still you are able to access the data and information around the globe. The sharing database to multiple users at the same time by ensuring the integrity. Yes, you can share, the many people can use the same data at the same time. That's also possible because of computer network. So that's why we need a computer network. Okay, so we learn something about the introductions, how computer network started, and let us learn how it works. The ARPANET, the Advanced Research Project for, you can have an advanced research, ARPANET means advanced research, can think, Advanced Research Project Agency Network. So Advanced Research Project Agency Network, you can think Advanced Research Project, ARP. We can have an agency network. So was one of the world's first operational packet switching technique. We'll learn about what is packet switching. So advanced research project, maybe sometimes what is expansion of ARPANET, sometimes they may ask, so you should be able to write this. Advanced Research Project, ARP. Project Agency Network. So A stands for agency, agency network. Very simple, you can remember this one. So one of the world's first operational packet switching network. So we learn about packet switching, that is they connected physically. Like one computer to another computers, they are connected physically. The circuit is formed, so using that. That's a physical connection exists. Now we use a wireless, then a satellite communication also. Don't let us rethink that's a circuit switching. The first network to implement TCP/IP, that is a transmission control protocol, internet protocol, that we are going to discuss, and it's one of becomes the global internet. So today also we use the same thing. The network was initially funded by the Advanced Research Project, ARPA, agency. Later, so DARPA within the US Department of Defense. So they have used for this project, so to development the network at the university research laboratories in the US. Okay, the packet switching of the ARPANET ARPANET together with the TCP/IP would form the backbone of the network. How the network works, that is how it works. That is, the network is formed like earlier networking concept. So which is with the help of TCP, that's a transmit IP address, along with the packet switching technique. So they are formed the network. Let us learn the OSI referential model, how computer network works. So what are the, let us we have a model. So when two computers are connected, and what are the, how they are able to send and receive, how they are able to communicate means there is a model, how it works. So this is a OSI model we call. We have open source interface. We'll discuss on this. Like, look at this. There is a 7 layer. The first layer is called physical layer. Then we have a data link layer. Then we have a network layer. Then we have a transport layer. Then we have a session layer. Then we have a presentation layer. We have an application layer. So each layer does a specific task. Like physical layer, when you talk about physical layer means it is how physically two computers are connected. So that is what we are going to discuss. Data link means how data can be sent from one, that's data transmission of data, that's a data link. It's concerned about data movement of data. A network means how data can be sent from one computer, how many paths exist between two computers, what are the cables, connections available. Transport means actually sending the data from one computer to another computer. Session means it's a connection between two computers during that time, so no other interfaces or interconnect or disturbing, just data will be sent in. Then it is presenting. After you getting the data some other way to other computers, and then it's a reformed, restructured, then you presentation. Then application, that will be you are using like web browsers or some type of applications where you can see the data has been received from one computer to other computers. That is what the 7-layer protocol, 7-layer architecture. We have a computer network. Let us we go in detail about each layers one by one. The first one is called a physical layer. I think you already have told just abstract view of these layers. So when we go in detail, so you are able to understand what exactly, at the end of this chapter, you will be exactly knowing, oh, this is the reason, so we have this layer, this is the reason, this is the layer. I think after this class you will be understanding. The first one is called a physical layer, already I have said. The physical layer is concerned with the transmitting raw bits, that's raw data, we call it bits in the form of zeros and or a communication channel. It also deals with the mechanical, that's a devices, electrical and timing interfaces. So this is a physical layer is mainly concerned with the transmitting of raw bits or raw data, or a communication channel. We have physical connection, how? So maybe mechanical, electrical and timing interfaces, when these two computers are connected, how they will be transmitting, how. So it's like hardware components. All hardware components will be dealt with a physical layer. So in physical layer, whenever you going to form a network means first is a physical layer. So in physical layer, what we try to do means how these two computers has to be connected. What is the channel exist? How channel I can establish? Should I use a mechanical devices to connect between these two computers? Should I use electrical connections? And timing interface, how the data can be sent and received. So this is what we do at physical layer. So that's what network, that's how we are going to form a network. The most important is we have to connect two computers. How do you connect two computers? That is the physical layer. So then we have a data link layer. The main function of data link layer is to transform raw transmission facility into a line that appears free of undetected transmission errors to the network layer. So data link layer means it is to link the data. What we have, the data has to be transmitted from one computer to other computer. So that has to be linked. What we have a data bits, physical layer, just it's a physical connections establishing. Now exactly how data move from one computer, so how data is transmission, how data transformation takes place without any errors. We should not, so it has to take care of when data are moving from one computer to other computers over the network, so they are safe, they are not there should not be any errors. So that is what data link layer is, to link data, this from, that's like transmit data from one computer to other computer over a line. We have normally we have a connections, so electrical cables, so through which we are sending data. So that data has to traverse, that data has to go. So there should not be any, so it has to make sure, or it should ensure that the data are transmitting properly. That is whenever we, second task, second step is, let us think we have a cable, data is moving from this computer to other computer. Is there no problem? There is no problem. We have to ensure. So that is what we are trying to think in the data link layer. So that is something about the data link layer. So next we have a network layer. The network layer controls the operation of subnet. The main function is to determine how packets are routed from source to destination. So network means normally what happens, many computers are connected. So there may be a subnet, interconnection of many networks. So maybe we have 5 computers interconnected, another 5 computers interconnected. So all 20, 30 computers are interconnected. Now what happens means, so we have to choose the proper path, that is from source to destination. So how packets means data. So data is divided into small packets. Sometimes they also called as datagrams. Now what happens, these packets has to be routed. So how do you transfer? How do you establish a physical path? That's a route. So this is the way data has to be transferred. This is like establishing source and destination. Just we are making just path. Maybe you think there are many connections maybe available. You can think in that way also. What I'm trying to explain. So let me write that one if possible. I don't want this. Let me explain. Okay. Okay, it's not supporting. It's okay, no problems. I think what I'm trying to say. Okay. So what I'm trying to say means, so there may be many paths. So you just imagine. So when you have a 10 or 20 computers, or maybe you think, if you take a simple example of Vidyaniketan college, and then you have the route. Where is the route? Actually, you are traveling from Virajpet to Vidyaniketan. So there are many paths. You can come via Bonikoba bus stand, then Panampeta road, take left, or you can take bypass. And also another way is also there, like Arvattuklu, somewhere you go and come back again, join through the Kadlayappa temple route. So like this, there are many paths. So there, that physical connection, that is what we have a layer. That network route has to be identified. That is the job of network layer. So in network layer means when you have many computers are interconnected, I have to route them. So there should be like what we call like roads. The roads are we have to create. So that is from where to where means source to destination. How do you make that one? That is the job of network layer. So next is the transport layer. The transport layer, the basic function of transport layer is to accept data from the above layer, that's from the network layer, and split it into a small units if needed, and pass these to the network layer and ensure that all the pieces arrive correctly at the other end. It also determines the type of service to provide to the session layer. So now what happens means, we have seen, we have a roads or exist. So through that we have to move, like you move from bus, sometimes you come from college bus from Virajpet, or maybe comes by car or some other means of coming. That is what transport. From this route map or from this route, so actual data has to be transmitted. That data has to travel. That is like through, we have seen, through the lorries, there are so many materials will come. Similar way, if you think yourself as a data packet, so you will be coming. There are many, in a bus, there are many packets, like many students. All comes and reaches the destination. That is how transport layer. Transport layer is actually cause for movement of data. And what happens when they come, so they may be coming differently. So one comes by bus, another comes by car, another comes by jeep, something like this. All reach the destination, all will be correct at the same place, arrive correctly at other end. So because normally what happens, data will be divided into number of packets. We call this a small packets, and their order gets crumbled sometimes. So the first packet comes last and last packet may come first. So this is the job of a transport layer to ensure they correctly arrive and rearrange them. That is what the transport layer, and also it provides the session. Now I'm sending 20 packets of data example. So it has the time. Now session layer will also provide some type of service. That's what service is giving to the session layer. So now I'm saying 20 packets or maybe 100 packets. So the session layer will establish a session. How long these source destination path must exist. So this is how it is going to form. I think it's just imagination, you have to think in real life exactly the same way we are trying to do. So whenever we have to establish some communication means, we establish communication path, first to road, something like this. That's a physical layer. The second, what we are trying to discuss is how we move. That is the concern. The next is network, how the data will be transmitted from one computer. That's through the road. Then we have a transport, how this data will be moving. It is exactly similar what we do in real life. It's also exactly similar, but the movements not with the humans. It is with the data. That's all. Remaining is, I think, once again you read with that imagination, you're able to understand exactly how network works. How you can take a map in a real Gonikopa or Virajpet map. It shows every paths, every connections, and how source. There also you can identify this is my house, this is their house, and you can out the path you can move from this is the direction. Exactly the same way we have a network to be formed. So that's how we'll be discussing. That is something about transport layer. So next is the session layer. The session layer allows users on different machines to establish sessions between them. So it includes dialogue control, token management, and synchronization. Now what happens? So physically connected, and there is a path, there is a network route is also there. There is also data transmission is ready. Now how long should this? Because I'm sending source to destination means there are many computers connected over the same path. There is many. Then what happens? We have to acknowledge. We have to confirm. I'm sending data to this system, another system. Another system should also respond. Yes, I am ready, I'm willing to accept data. So this is taken place. How means that is what we call as a session. So in session layer, that's why we have a token management. We send token. And this source machine sends the token, that's the signal. I'm sending this amount of data. And destination machine will acknowledge, yes, it also sends the a token saying that, yes, you can, I'm willing to accept. Then the data has been sent. So, and also dialogue control. So that dialogue control means establishing connection and synchronization. So how long they should remain synchronized, how long data, until the data has been exchanged, though they should be synchronized. So this is what we are trying to do in a session layer. And one more, what we have is the presentation layer. The presentation layer is concerned with the syntax and semantics of the information transmitted, concerned with the moving bits around the layer. Now what happens means the presentation layer is actually the syntax, how it should be presented, how it should look like, and what are the logics to be, the way it has to be transmitted, and moving the bits around the layer. So there are so many, data will come in different form, different, that has to be restructured, reconstructed, which is received. The present layer is concerned with the syntax and semantics. So this is how data has to be presented. That is what I have to be reconstructed. In presentation layer, we try to represent as according to the syntax and semantics of the information. So that is what that's a word presentation. We are trying to present, because from the source machine it is reached the destination machine after the session synchronized and all data has been transmitted, and then presentation layer means present the data according to the syntax, how it is needed. So that is what the presentation layer. So next is the application layer. The application layer contains a variety of protocols that commonly needed by the user. For example, so application layer means we need to exchange the data between two computers. That's why we learn about this HTTP and WWW, all these things. So for example, HTTP, Hypertext Transfer Protocol. So how two computers can exchange the data. There is a standard protocols, the standard rules. Protocol means set of standards should be followed by two or more computers. That is, which is the basis for the World Wide Web. So I think today also you can type there is a HTTP, www.google.com means before this www, there we can see HTTP. That is trying to link your computers or the server. So then you are able to exchange data between the server and your computer, local computers, that we will understand. So that's application layer is a variety of protocols, how the data can be sent and received by the computers. So that's what we are going to discuss. This is something about the application layer. So totally we have 7 layers. I think now you got an idea of how computer network works. One is a physical layer, then we have a data link layer, and then we have a network layer, and then we have a transport layer, and we have a session layer, and then we have a presentation layer, and then we have a application layer. So I think now it's very exactly you understood how this all the stages, you can think all layers are required. in order to send data from one computer to another computers. So this is something about OSI model, open source interface. We'll discuss that later on. So next, I think sometimes they may ask in exams, explain data link layer, explain physical link, 1 mark sometimes, or mention the OSI reference model. Sometimes they may ask in the exam, so it's better to read. Or it's very interesting. You can go with, read once again. So next we have a transmission. I told about TCP IP protocols, transmission control protocol, and there is internet protocol. So TCP IP is a layered set of protocols. So this protocol assumes that there is a way to communicate reliably between two computers, like mail, like other application protocols, simply defines a set of commands and messages to be sent. TCP is responsible for making sure that the commands get through to the other end. It keeps track of what is sent and retransmits anything that did not get through. So this is a protocols. Remember almost what is protocol means, it's set of standards. It's like some command, some set of standards where two or more computers are able to communicate. So this is one of the reliable transmission protocols used by earlier, like any digital application protocols. It defines set of commands and messages to be sent. So how these messages sent from one computer to another computer, and responsible for making sure that the commands get through to the other end. It is correctly transmitted from one computer to another computer. That is, directly takes care of what has been sent, and it keeps track whether it has been reached or not. Should I resend it? Anything that not get through that, which is not reached. So that is what is the basic. It was used earlier, and today still we use this one for a local area network. TCP IP, it's IP address, internet protocol address, still we use in order to reach the destination. So that is what transmission control or internet protocols. So there is some explanation about this, how it works. Already I told. So TCP is the base communication protocol of the internet. So whenever we have means it's a network of network is called internet. We have one set of computer networks, we have another set of computer networks. So these two computers are interconnected. So that is what we call as the internet. So there we use that's a base, because local area network we have this standard. So all computer networks, many networks, millions of networks will be there. They are interconnected by this TCP IP. That's why it's a base communication protocol of the internet. the part of normally what happens here, we have a IP that is called IP address we use. So IP address means it's a numeric number. So because everyone in this world is identified by unique name, or you have some address for each one of us. Similar way, so when internet, many computers are interconnected, and each computer should be able to identify. How do you identify computer means? No, I'm using HP, I'm using IBM. It is not like that. So actually, every computers will have a IP address. That's a unique address. It's a number. So we'll discuss that one. So using that address, like you have your door number, exactly when it is connected to the network, many computers are connected. There, your computer has got unique IP address where other computers do not have the same address. That's how you can easily identify over the network. So IP address to join to the network segment. So that's IP address I told. So TCP part, other parts we have split into two parts. One is the address to join to the network, and another TCP part of the provides a reliable delivery of message. That's a transmission between network computers. How exactly data will be sent? This will be taken care by TCP IP, and this will be used to connect to the network. So it is based on the CatNet model. So this model assumes that there is a large number of independent networks connected together by gateways. Already I have told. So there are many computers. Like you get into apartments. So there are many apartments in a single area. Maybe you think like this. It's normally in Bangalore, many places you go, or you get into the layout. So when you're entering the layout, there are many houses. So there may be some places they are also connected to other layout, something like this. So that's through the gateways. Normally we have many computers, all are interconnected, large number of networks. That's what independent networks connected together by gateways. The user should be able to access computers and other resources on any of these networks. So what is the main important of network is to share the information. So now what happens, I am in some other place, I should be able to access some other computers over the networks. Not the same networks, maybe a different network. So that is what is more important. So that is how this network works. So that, yes, it is possible, able to access the computers or other resources on any of these networks. As I told, there's a large number of independent networks. So we have a large number of independent networks, and among these networks, so any computer can access any other computers, or any resources available through any other networks could also be accessed by all the computers or the network. So that is the main cause of the network. That's the main reason of having networks. So we have a datagram, so that's a small a part of data. Will often pass through dozens of different networks before getting their final destination. So whenever I send something means, no, you have a row houses means, so you want to reach the last house means, so obviously you have to go from first house, second house, third house, whether you're not entering, but you have to pass through. In exactly similar way, so we have some small packet or small datagram. So that's a small part of unit of data, and it has to pass through dozens of different networks before getting the final destination. Of course, you want to reach the destination means it has to go through all these individual computers, all these individual computers before it reaches the destination. Maybe many networks. The routing is needed to accomplish this should completely invisible to the user. The routing, actually this doesn't know. So if my computer is how it is going technical and reaching the destination, definitely I am not going to identify. It's invisible to the user. As far as the user is concerned, all you need to know is the internet address. So if I want to access some other computer means, I must know internet address, where exactly your house is. Something like I want address, then only I can come reach. Exactly in computer network also, if you want to reach the particular computers, you need to have the address. So in order to access another system, we need address, internet address. So this address is something that looks like 4-bit. You can see here 128 point. This is called IP address. Okay, so it's very important. So I think most of computers will have, because it's just a 4-bit. So you maybe remember it's a different. So we have totally 32 bits number. So we have here 1, 2, 3, 4. So actually 8 bits. So this is 8-bit, this is 8-bit, this is 8-bit, 8-bit, totally 32 bits. So however, it is normally written as a 4-bit decimal number. So we have 4-bit decimal numbers, 1, first already explained. So each represents 8 bits of the address. The term octet is used by internet kind of documentation for such octet chunks. Normally they use. The term byte is not used because the byte is a group of 8 bits. It supports some computers that have byte size other than 8 bits. So therefore they don't use this one. 32 bit, 64 bit, there are maybe other sizes of computer, individual computers. So therefore we don't use the byte term. So it's still we use 8 bits only. So this is something about the TCP. Let us continue something about this, the same thing. So generally the structure of address gives you some information about how to get into the system. So normally that's why hackers normally they log into your computers through the IP address. That's a one-way loophole. That is a one way of identifying who you are in the network. So if I know the address, I will reach your home. Exactly. So it may be good or bad. So even good people will reach your home. Even thief will also come reach. Make something. You will also reach, because once we know the address. That's what the address is very important. Generally, the structure of the address gives you some information about how to get into the system. So we normally refer to the systems by name. Normally, where I give a name to the system. This is Vidya Niketan 1, Vidya 1, Vidya 2, Vidya 3, or some name you may give also. But the name is not considered. So rather than by internet address, we do not use the system names. It doesn't, many people having the same name, computer name, addresses. So therefore, we have to use the IP address. So when we specify name, the network software looks it up in the database and comes up with the corresponding internet address. Even you gave the name, it goes like door number. As I told, there may be many people with same name. So, but how they are different means it's address. So we look like postman work. They took the address and they'll search the door number. According to the door number, they reach. So most of the network software deals strictly in terms of addresses only. That's why nowadays IP address is compulsory. Every house, the door number is like we use. Sometimes it's a locality, or if it is some area means pin code is compulsory. Through the pin code only, it becomes very easy. Similar way, this also the same. So TCP/IP is built on connectionless technology. Information is transferred as a sequence of datagrams. Already I have told. So you have own computers, then you can. It's need not to be connected, but it's already built in. But once you establish a connection with the networks, So then automatically it is used to connect. So normally data will be transferred in terms of the information or data, whatever we call, that is transferred as a sequence of datagrams. It's a small packets. So each of these datagrams is sent through the network individually. So normally we send. So there are a provision to open connection. You can choose any one and you can choose. That is to start conversation that will continue for some time. However, at some level, information from those connections is broken up into datagrams, and those datagrams are treated by the network completely separate. For example, suppose you want to transfer 15,000 bytes of file. So most network can handle 15,000 octet bytes datagram. So what they do means, so the protocols will break this up to into something like 500, and each of these datagrams will be sent to other end. At that point, they will be put back together into, again, the reconstructed to 15,000. However, while those datagrams are in transmit, the network doesn't know that there is a connection between them. It is perfectly possible that datagram 14 will actually arrive before 13. It's also possible that somewhere in the network an error will occur, and sometimes it's also possible. So it is then it's possible that somewhere in the network, and some datagram won't get through at all. So in that case, datagram has to be sent again. Note, by the way, that the terms datagram and packets often seems to be nearly interchangeable. Technically, datagram is the right word to use when you're describing TCP/IP. So now what happens means, so normally whenever we transmit data through the IP address, and then what happens, sometimes there is a next to you means it may be available within the next to your computer means you can easily establish a link and then you can transmit data. So normally what happens when you have a larger networks, many networks, the data from source to destination may not have a sufficient bandwidth. You cannot send, like take an example of 15,000 of data you want to send means byte of data, the storage unit, then you cannot send. What we do means they split it into 500 packets or datagrams. So this 500 will be sent. Like we cannot send entire thing means we broke and make it into packets. You have seen in when maybe you take a coffee when you are sending, you have so many things and then what we do, we want to send from your home to the market means what we do, or like APMC or somewhere you are sending means, then you make it as a packet. You fill a small packet and you load it to the lorry, and then it is sent in exactly similar after receiving. Then maybe you are sending 3 loads, 1 load, or only 5 loads, something like this. So then differently we go. Sometimes what you send first may reach last. What you send last may reach first, or something like this. Here what happens means, since I broken the same information data, so when you reach the destination, there are possibilities. As I told, the data which is free may move faster and reach the destination early. And what happens, some data may not be collapsed and lost data, and it has to make sure that, again we have to have transmission control TCP, that has to take care, either resending again. Is it collapsed? It is ensuring, yes, it reached the destination, all packets are reached the destination safely. Then after reaching them, so again we have to reconstruct as it was before in the source machine. So that is reconstructing is done. That is what all the task is going to be done by the TCP, transmission control protocol. And we have a IP, that's an internet protocol, it's to use the address linking. So this is how the network works. So we need both TCP and IP, and TCP part control protocol. So this is how data will be sent and received. How it is concentrating more on the communication, how data will be sent and received. And IP address is trying to link your source computer to the network. That's how they can form a computer network. There's something about, there is the same thing they have used, datagram, sometimes a unit of data as a part of data, which is what the protocols deals with, the lower level. We have protocols deals. A packet is a physical thing, a circuit normally appearing on Ethernet or some wire. Some data is sent through the wire. That is what is called as a packet. However, they are both relevant to data only. So therefore, they are the same. And we have other transmission protocols. We discuss one by one. So HTTP already I have told. So hypertext transmission transfer protocol. So HTTP stands for hypertext transfer protocol. I think hypertext transfer protocol is a protocol and speed necessary for distributed collaborative hypermedia information system. HTTP allows open-ended set of methods to be used. So indicate the purpose of request. It builds on the discipline of reference provided by the URL, Uniform Resource Identifier, and location name URN, indicating the the source on which method is to be applied. So messages are passed to HTTP in a format similar to that is used by mail and multipurpose internet mail extension. So this was the multipurpose mail internet mail extension. So multipurpose internet mail extension. So this is the same what we call protocol used. What happens means hypertext transmission protocol. So normally this HTTP, so it's like related to the web server. So web browser and web server. So there are two things. So when like normally hypermedia, any we can think hypermedia means so anything on the web, you're watching video, web page, document on the World Wide Web is a hyper, anything, any video. So there is a necessity of actually we have to distribute, already distributed, and many computers are trying to access that same resource. So how do you access means like read and request. So HTTP, your browser asking HTTP, I want this data. Like when you type the something like www.google.com, so that HT transmission protocol request. So that through the URL, that is a uniform resource locator, whatever you type, so that keep changing. So you type something Gonikopal, so that you can see their browser, it comes slash with something else. So that URL, that's a uniform URL, what we call, it keeps updating, it keeps changing because it is pointing exactly the same location where this particular content is present. So that is the job of hypertext transmission protocol. So whenever data is transmitted, it's like you're asking something and you have to get it, means that is a URL name you have to use, or URL you have to use, interface identifier we have to looking for. So through this, and there is a standard, there's a way of exchanging, there is a protocol. So when I ask something www.facebook.com, and there is somewhere in the server that is there, that has to come to your computer, means there should be some standard, some way of collaborating, some way of accessing, some way of link has to be established. That is what the role played by hypertext transmission protocol. Protocols mean standards for exchanging data between one or more computers. So this HTTP hypertext we are talking means all hypermedia. It's exclusively for the World Wide Web. On the websites or web servers, there is a movement of data. That is how they are. So they use similar to that is used in the internet mail. That is internet mail extension. We have one more. So multi-purpose internet mail extension. This year they asked for this expansion. All expansion in this chapter was going to be important. Not in this chapter, everywhere. Whenever we learn something about expansion, abbreviations is most important. Never forget. 1 marks they usually ask in the exams. So HTTP has a various built-in request methods, which allows, methods means like functions, what we are learning. So don't think methods is something else. So method is nothing but just functions in C++. So allows user to read the web page. You want to read web page, so header or something like a store web page, or to append named resources, or to remove the web page, or to connect to existing resource, or break an existing connection between two resources. So that is exactly I told. So HTTP is a various built-in request. So this protocol has inside many things. That is to read web pages. It allows you to read web page, and also it allows you to read web page header, what is the title of the web page, and store a web page. If you want, you can store that web page, copy, download web page, or append to a named resource, or to remove the web page, or you do not want, you can remove also that protocol, or to connect two existing resources, or already via means that also connect or break existing connection between two resources. And this is what the facilities available with HTTP, Hypertext Transmission Protocol. So next we have a file transfer protocol. I think we'll finish it off up to these protocols. So file transfer protocol. So as the name suggests, it's the file transmit. So we have to transmit entire file from one computer to another computers. What are the standards to be followed? So that is what the file transfer protocol. One of the original services on the internet was designed to allow for transforming files from one system to another system. It goes by the name FTP. Whenever file is sent over the network, means it goes in terms of FTP, which stands for File Transfer Protocol. File Transfer Protocol. This is very important. So of any type can be transferred, although you may have to specify whether the file is in ASCII or in binary form. So already discussed about the file in be in ASCII, text file, or it should be in the binary. Though they can be transferred to any system on the internet, provided that the permissions are set accordingly. You can send from one computer to another computers, and you have permissions to send this according to the format you have sent, and the destination machine can also accept this. They have a set of standard permissions, so then you can transmit. That is something about file transmission protocol. This was the earlier they are using. So normally the file FTP, it is sent in the form of FTP. So we have to mention what type of file you are sending, whether it's in ASCII form or in binary form, and then the files will be transferred from one computer to other computers. So it's very useful. There are some advantages. It's very useful to transfer file from one network to another. Yes, of course, that's what the use of file transfers, where it becomes useful for transfer of files from one computer to network to another computer network. It's an effective way to get geographically dispersed group to cooperate on a project. So now dispersed group means they are physically at different places. Dispersed at group to cooperate on project. So all people are working together. Some people from the US working, some people from India working, some people from UK, all are working now. What happens? They are physically different. The project is ongoing. So geographically they're different place. Now what happens? We have to communicate. We have to send and receive file. This is a part of a project I have done. This is a part of project I have done. So they have to communicate. So this file FTP becomes very effective in such places. And next, one more advantage is it's a popular way to share information over the internet. FTP works as a client-server process. It's one of the way of sharing the information. So it's one of the, it's like client-server. So you are requesting, and server another will be processing. That's, you ask for it and it will be delivered. So it's a popular way of sharing information over the internet. So next we have a serial line internet protocol. Serial, we can write SLIP. Serial line internet protocol was the first protocol for relaying the IP packets over dial-up lines. So it defines an encapsulation mechanism with a little easy. There is no support for dynamic address assignment, link testing, multiplexing different protocols over a single link. A SLIP has been largely supplanted by PPP, point-to-point protocols. So this was earlier we have used dial-up network we call, and earlier telephone connections we are using this technique. So it is dial-up lines, telephone lines. It defines an encapsulation that is binding data. It's easier method. So what you are sending data, that is bind from source to destination, and your data is captured, secured, and it is sent. That's why it's dial-up. First we have to establish the connections, then you can send the data. There is no support for dynamic address assignment. So there is no support. It does not support for dynamic. So once beginning, well, it's a static address. So you must know exactly where I have to send, and that address is existing, then only it is performing. And also it does not for link testing, whether that link exists or not. So once you set up the destination, automatically it will sending. That's all. So multiplexing different protocols, multiplexing or different protocols over a single networks. It's not possible. So what is multiplexing means? It taking a many input and sending the single output. It's a multiplexing. But what happens? This one, this SLIP will not have that one. So when many protocols, that's a many link comes, and also we have to send a single link. So many protocols are asking, and you have to combine this. All are asking for the same source. You think like that. Then what happens? All has to be guided to that one. That is not possible. So and this is largely suppressed by PPP. Now we use a PPP, point-to-point protocols. The point-to-point is the internet standard transmission of IP packets over serial lines, that's telephone lines. The triple P is currently the best solution for dial-up internet connections. Now we don't use this one, including ISDN. So triple P is a layered protocol starting with the link control protocol, LCP, that's what we do not have, link control protocol, link establishment, configuration and testing. So all this possible before it does the task internet connection, so it establishes all these things. Once the LCP, that is link control protocol, is initialized, yes, it is ready, one or many of several network control protocols can be used to transport traffic for a particular protocol suite. According to the your network suite, different network data traffics is available, transport traffic is also available. So according to transport, which is less, that is depending on that, it decides. The IP control protocol permits the transmit of IP packets over a triple P link. Triple P supports both synchronized and unsynchronized lines. So if you are connected physically from one computer to another computer, yes, you can, data will be transferred. Even it is not connected, but still they are able to transmit from both one computer to another computer. So these are the different types of protocols used for establish a connection between two computers. So next we'll learn about the internet and we'll learn about it. So these are the theoretical chapters. So please go through the textbooks, read 1 or 2 times and listen to this class also. And like what you are reading, I'm doing the same thing and I'm highlighting the important things. So if just to go listen this carefully, and I've seen only 70 to 80 people are watching. I do not know other people, around 170, 160 at least minimum they must watch. I do not know what you are thinking, and this is going to be very difficult in the future. So try to concentrate, and I'm asking you to read more. So don't waste your time. Otherwise, once the exams are announced and you are enjoying life, I don't know whether you think, oh, okay, I don't have this and that. So I don't want to tell this kind of advice also. Maybe better you think of yourself. Already your future is in some dilemma. So concentrate. At least you have a knowledge, means something somewhere. You will get some exams announcers. No problem. You can do well. Only thing is important is knowledge. Try to gain knowledge. Okay. So if you have any doubts, let me know. Thank you.